This is SOL 8.5. The student will solve multi-step linear inequalities in two variables, including solving linear inequalities, justifying steps for solving inequalities, solving real-world problems, and solving systems of inequalities. Okay, solve for x, and you're going to type your answer in. So you're just going to try to get all the x's together, then get x by itself. The first thing we have to do is combine like terms on each side. 6x minus 13x becomes negative 7x minus 11 is less than 7 minus 5x. Then I want to get all the x's on one side, so I'm going to add 5x. And get negative 2x minus 11 is less than 7. Add 11 to both sides, so I get negative 2x is less than 18. Then I'm going to divide by negative 2 on both sides, so I get x is greater than negative 9. So remember, if you are dividing by a negative, you have to flip the sign. So what you can type in is x greater than negative 9, or they would have accepted negative 9 less than x, as long as your sign is facing the right way with regards to x. Okay, this one gives me multiple choice options, so you could plug this in and see which one makes the statement true, or we can just go ahead and solve. So again, combine like terms. 4x minus 11x is negative 7x minus 5 less than 23 minus 3x. Add 3x to both sides, so I get negative 4x minus 5 less than 23. Add 5, so I get negative 4x is less than 28. Divide by negative 4. I'm dividing by a negative, so I have to flip the sign. And I get x is greater than negative 7. So that would be B. And again, when you plug that in, it should make this inequality a true statement. Okay, justifying properties. So step 4 to step 5. So notice that they are multiplying by the inverse of negative 2. Okay, so even though they're giving you a bunch to choose from, notice the directions say choose a property that justifies the work between step 4 and 5. So inverse property of multiplication, because negative 2 times negative 1/2 will give us positive 1. So remember, inverse is where you end up with 1 for multiplication and 0 for addition. Identity is where you're multiplying by 1 or multiplying by 0. Okay, so I don't actually love this question because it says choose a property, which would mean to pick one. Technically, you're also multiplying by the same thing on both sides, so it would be multiplication property of inequality. I think if they gave you a question like this, especially with the select all that apply, they might not say to choose just one, because that would usually be multiple choice. So in this case, I think both would be correct. Technically, you can make an argument that it's just the multiplication property of inequality, because inverse property might lead you from step 5 to step 6, ending up with that 1. Okay, so technically I think if you had to choose one for this question, it would be multiplication property of inequality, because what you're doing from step 4 to step 5 is multiplying by the same thing on both sides. Okay, this one you are graphing an inequality, but you have to actually set up the inequality first. So Frank works at a convenience store. He earns $7.50 per hour when he works during the day, $12.50 per hour when he works at night, and wants to earn at least $300 per week. So notice that during the day is on the x-axis, and during the at night is on the y-axis. So I have $7.50 times during the day plus $12.50 at night. Now, he wants to earn at least $300 per week. So his earnings are going to be greater than or equal to $300. Okay, so the best way to do this one, because it's set up like this, is to find x and y intercepts. So to find the x-intercept, remember we make y 0. So you end up with 7.5x greater than or equal to 300. To solve for x, you're going to divide, and you end up with x is greater than or equal to 40. So on the x-axis, it needs to hit at 40. So you know it can't be C or B or D. So you know we're looking at C or A. Now you don't really need to find the y-intercept because notice they're both hitting at the same place. So now you need to just decide, is what he's going to earn, is that going to be greater than or equal to that line or less than or equal to that line? Remember, he said at least $300 per week, so he wants anything greater than or equal to those limitations. So it would be C. Okay, select all ordered pairs that are solutions to the system of linear inequalities. The best way to do this is just to take each point and plug it into both and make sure that it makes both true. Something else you could do to double check would be to put both in slope-intercept form, graph it on your calculator, and then see which ones fall in the intersection of the two inequalities. Okay, so if I plug in 1, -3, I get -3 less than 1 minus 2 would be -1. So that one's true, but then 4 times 1 is 4 plus -6 would be -2, which is not greater than or equal to 8. So do not click A. For B, let's see, 6 minus 2 is 4, greater than -2, so it makes that one true. 4 times 6 is 24, minus 4 is still greater than or equal to 8. So it makes both true, so you are going to click on B. For C, 2 minus 2 is 0. 8 plus 0 is greater than or equal to 8, and because that's greater than or equal to, it does make that one true. 5, 1, 5 minus 2 is not 1, so right off the bat it doesn't work. 3 minus 2 is 1, not 3, so... Oh, I'm sorry, it's not equal. So 5 minus 2 is 3, which is greater than 1, so that does make that one true for D. And then 4 times 5 is 20, plus 2 is 22 is greater than or equal to 8, does make that one true as well. So we are going to click letter D. 3 minus 2 is 1, which is not greater than 3, so it's not E. 0 minus 2 is -2, which is not greater than 4, so it's not F. So you would click B, C, and D. Okay, for this one, you would drag and drop two inequalities to build this system. So it's kind of like going backwards. So notice that we have one solid line, one dotted line. The solid line is negative, so the negative slopes that we have to choose from here, the ones on the left, we're looking for a solid line, so we can go ahead and rule those out. It has to be either one of these down here. So then you're looking at, with that solid line, is it shaded above or below? Well, it's shaded above, so y is going to be greater than or equal to that line. So if this were drag and drop, you would drag this one up here. And then we're looking for the second equation, which notice they're written a little bit differently, so you have to be careful. You could always rewrite them with y written first. It is a dotted line, so again, not those. And then you got to ask yourself, is y less than that or greater than that. So if you look at the dotted line, it is technically shaded below, so it's going to be less than that dotted line. This first option, if you rewrite it the way we normally write it, y is less than 2x plus 5, even though 2x plus 5 is written first. So you would choose this one. Be careful not to pick this just because it says less than. We are talking about y, the output, being less than. So you would take this and drag it right there. Okay, another system of equations. The easiest way is probably going to be to graph this in your calculator. This one's already in slope-intercept form, so type it in like that. Make sure you put 2/3 in parentheses. Here I need to get y by itself. So if I subtract 5x, I get 6y less than or equal to negative 5x minus 30. Divide by 6, y is less than or equal to negative 5, 6x. Divide by 6 minus 5. Okay, so now if you graph this in your calculator, you will see that the only place that they both are shaded, where there's crisscross, is section 2. Now we can double check that algebraically. This line is the solid one right there because it has a y-intercept of negative 5, and y is less than or equal to that. So it has to be either 2 or 3 would be less than that line. And then y is greater than or equal to 2/3 plus 1. That's this line right here. And so of 2 and 3, the one that's greater than is 2. So calculator or doing it by hand, either way is fine. Or you could do one and then double check with the other. And that's it for this one.